Hello y'all, this is Joe Smo. Today we will be discussing how to make a patch that is of a decent size. So we're not going to just be like editing one number this time. We will instead be editing multiple numbers. I already have the patch made. It has 5 different parts to this patch, but as you can see, it is very lengthy, to say the least. So the 5 parts, I already did this, I recorded this episode a few times. Got interrupted, and didn't like the first recording. So each world gets 4 animation frames. So let's say you didn't want the same animation frames for all the worlds. Instead, you would like multiple frames. You can do that here. Each animation time can be changed, so the speeds of the animations can be changed. Worlds can have animations disabled, so if you don't want animations like World 5, which was used in the game, you can do that as well. Screens can have the animations disabled as well. And bridge animations can be enabled for each world. So World 3 uses bridge animations. You can tell by the bushes not swaying all the way. But so I already had this from the previous episode, but so you first want to write your comment in, whose patch this is, who's making it, and a little title, and exactly what you want it to do. I already set that up. I'm going to delete this, and then you want to locate the code. So for this episode, I know exactly where this will be. You want to go to, that's not useful. You want to go to your compiler program. So SMB3 master program 11 ASM. Shove that into your like Notepad++ or Visual Studios, and you should be good to go. Once there, you might notice that I have slightly prettier colors. It helps like see exactly what's happening. So you want to go to define your language. You want to hit import. Then you're going to have to download for Notepad++. You're going to have to download a 6502 like a language support or extension or whatever you really want to call it. And in that file, you will get a .xml file. You're going to click that. You're going to hit open, and then it will provide you with a lot of help. The one I found did not have this by default, but all you had to do was type in if, else, if, and end if. And then I wrote Valiant and then word. I'm also going to write another few words in as well. Remember, this is all personal preference, so if you don't want that for any particular reason, you don't have to. I'm going to write macro as well as in macro. And next out. And I also know that mine's like, it's not white. You can go to style config and just play around with the colors, and you will notice it will change the ability to be red to to your personal preference. Like if you want like blue, you can do that. I just want black. And then I scrolled all the way down to our code. I simply copy this and put it into my changes.asm. You don't have my changes ASM. So what you will want to do if you don't have one is you want to go to the patch. So the name of this is tutorial patch. You're going to the simplest way to do this is just get the smp3 file, copy it, paste it, and then open it up, Control A, delete everything in case, or you can just make it like new text file and make it ASM as well. That works as well. You want to do that. It really doesn't matter as long as you get an ASM file. I didn't want that to happen. Okay, so the first episode in this episode, we will be explaining exactly how everything will be working. So as you see, there are two arrays. I can tell there's two arrays. So by a label followed by bytes or words. So this is an array. This is an array. This is an array, so on. So you might be wondering, like, where are the non-arrays? So just like regular declarations, those are all done inside the code itself instead of like outside, like you would normally expect for like most normal languages. Now past this point, you will actually get into the code. So this one does animations, this one does the graphics. World num is the world you are on, so wherever Mario is world num. And you see it says compare to 4 instead of 5, right? That's kind of weird, you know. World 5 is to the game world 4, and this is because computers read 0 as the first number instead of 1. And and that might be a little bit complex to get used to, and there's actually a way to make that not have to be a problem. So you're gonna want to go up to the top so it's easy to find and locate. And you're gonna name this, the technical name is macros, and you're gonna start with macro, and then in macro. So macro and macro are like parentheses or brackets that they have the buddies. You gotta have them in pairs or else they don't work. And then the macro has to get a name. So let's just call this world world num change. Correct. Yeah. Correct world num. And then let me see how I want to. I'm thinking about how I want to do this. And then you want to write value or any other name. Just know that value has to be repeated throughout this. Let me see. How I want to do this. So I don't know if you can actually return a value like you can in NestASM. Instead, I think what we need to do is, so from this value, we want to -1. But that doesn't actually do anything. So instead of doing a macro, that's a little bit advanced anyways, so I want to instead make it a little bit more simple and just make it a variable that we add to all the world nums, so it will work easier. And how we want to do this is just declarations. Then we want to write row num offset, and I want to equal -1. No, not negative. Yeah, -1. And now, instead of saying compare for, we will compare 5 plus world num offset. And now you can use the correct world that we are in instead of the 7 to represent 8 and so on, because that can be a little bit complex, especially once when you're beginning. So load X, what world we are on. Then we'll want to check if this is world 5, and if it's on world 5. If it's not world 5, because it's saying not equal. So if we're not on world 5, we go to this function. And you notice it might have a complex name. So let's just make this as simple as possible. Make this a plus, and make this a plus. If you're in NestASM, this isn't going to work, but since we are using ASM6, this is fine. The reason why is NestASM doesn't have any special labels. All labels have to have a different name, so using plus more than once leads to problems. But ASM6 has this feature, which just makes life a lot easier. That's one main reason why I prefer it over NestASM. So then we have this little part right here. So if it's world 5, it's going to load 0, 0. So what you need to know about y equaling 0, 0 is that's the frame. And we're going to branch all the time. And you know, you might not like BPL. You can change that to something else. So let's say equal, because we know the register prior is 0, so it's always going to branch. And let's just showing this so it's easy to read. So any world besides 5, compare world 8 plus world num offset. And then you see this again, and that might be too complicated again, so just you reuse plus, so it's easier to read. So plus goes forward, minus signs go backwards. So hopefully that helps you out if you're having compiler errors. Just know that pluses go forward and negative signs go backwards. So if it's not world 8, so keep in mind that X is still a world num. So compare X is 8. If it's 8, it continues onward. If it's not 8, it gets branched all the way up here. So these branch instructions go either forward or backwards 128 places, more or less. So these can't like just from here go all the way to the very bottom, or else it will complain in the compiler, because the compiler will not be able to put a number in there that's going to warp you all the way down there. And hopefully, once we get done with this patch, we will discuss a method to get past that limitation, though, in which we will learn a little bit more of the complex opcodes to try to circumnavigate that problem. And then you see load to Y player current. So this is the let me look. So this is basically where the player is, and then we load a world map X high by the player current offset. So basically all you need to know about that is that this just figures out what screen the player is on. And then we compare it against 3. So 3 is a screen. It's the 4th screen. So you start on screen 0, then 1, and then 2, and then 3. And for Bowser's Castle, that's the last screen. And because the walls look glitchy if it animates, we only have 1 frame, so it doesn't animate. So if we're not on that screen, we skip and continue on with our Mary on life. But if not, we don't animate. It's the same thing as up here. If you don't want, so we can also make a macro to handle that. So if seeing code is kind of hard for you to like comprehend, you can use macros to try to make it a little bit easier. Basically this just makes it so you don't have to see like some similar code get used over and over again. So use it multiple times. That's typically the idea with macros. So we can say go to end of, what is it? Don't animate. Let's just say don't animate. Don't animate. Okay. And then we're going to have macro at the beginning, and then at the end in macro. And then we write a comment. Make overworld not animate. This won't take in any values or anything, so we don't have to worry about that. And now we're just going to steal this code, plop it right there. Delete the comments. Set animation frame to 0. And then we want to end routine. So now we can just write don't animate. And let's just to make sure this name isn't used at any other point, we'll want to give this map underscore don't animate. And now instead of writing this, we can get rid of that. We can do map don't animate. And then where it doesn't animate here, we can do map don't animate. And that will do the same exact thing, but now it's a lot easier to read. because you know it doesn't animate there, and it jumps to a macro to do that. But remember that it has to be a different name than all other things, so the compiler doesn't get confused. A thing to keep in mind though, you can do this with any amount of code, but try to only do it with code you repeat. So we repeated that twice, so it's a little bit more acceptable, but you don't really want to do that because it can be a little bit more annoying to read if you don't know exactly what's going on. But as a beginner, it's a good thing to use and get used to. And if that needed like a value, so if we wanted to load a y a certain value, you can write value, comma, value 1, and then you can load a value, and it will load that value. You can also load RAM or any other value as well. And continuing on, those will load the map animation F, which stands for frame, and we're going to deck the tick, the animation tick. So this is basically the frame we are on, not the frame. Actually, let me rephrase that because there's a lot of frames going on. Okay, so there's the picture we are showing, and that's what we're loading to the Y register. So remember, there's 3 registers. The accumulator, which we use for most things, but it can't always be used because it's just too impossible. And then we have the Y register and the X register, which are used for loops mainly, but we haven't learned about loops that much, and indexing. So in this case, we're going to load a Y, the frame or the picture that's being shown. Then we're going to deck the time that this animation has been showing, and if that is ticks remain. So basically this says if it's positive or not 0, so basically the branch are not equal, we want to map no animation update, which is the don't animate. But this time it's not setting that value, so we don't want to write map don't animate, because we are animating it in the sense that it's still showing the same frame, it's just not doing anything to it. Okay, but if we went to 0 ticks, so we don't have any ticks remaining, we want to go to the next frame. This is go to next frame. So increase Y, so that's the frame we're on. Then we want to transfer Y to A, so the Y register is going to go to the A register, or the accumulator. So the accumulator now holds the frame. Keeping in mind that the X register still holds the world we are on, and this is asking if we are on world 3, we want to, and it has this annoying thing again, so let's just make that a lot easier to read. So let's just get rid of this. So basically, if it's not world 3, we go all the way down here to some other code. Then if it's world 3, we're going to so in world 3 you only have 2 animations, so to account for this, you only this and function. So let me just show this in comments. So there are a few possibilities. So either we have 0, 0, 0, 1, 1, 0, and then 1, 1 for the animations, because they get capped at forward down here. Okay, and we will discuss how that works once we get there. But these are the only possibilities. And what we do is we say we are only going to count the first and won't end the next one. So ANDing means both of these numbers. So this number and this number have to be the same in order to produce that number. 0 and 0 equals 0. 0 and 1, they're not the same, so it's 0. 0 and 0 equals 0. 1 and 1, that's 2 1s, so it's 1. 1 and 0 is a 0. 0 and a 1 is still 0 because they don't match. Then we have 1 and 0, that's not going to match. And 1 and 1, and now that's just 1. So we have 0, 1, 0, 1 from 4 different animation frames that we could have had. So we are effectively capping it off at 2 animations, because you see, instead of 4 animations we get 2. And you might be like, well, it still animates in World 3, and that's true. It does. So but that's not how it's done. So we load to a basically it says, is the bridge up or down, and if it's 0, it's down, and then we are going to skip the next part of the code. So this ORA, it might be a little bit confusing to read exactly what it's doing, but I'm going to do the same thing we just did, but now we want to do it in the sense of an ORA instruction. So we have 0, 1, and 0. I'm not going to write the other two because they are the same as these. So in this case, so 2 wrote out is this, so you can think about it equals 2. So 1, 0 is 2. If you don't feel comfortable converting like that, you can write instead of 2. So let's make these a little bit simpler to read. 0, 0, 0, 0, 0, 0, 0, 1, and 0, 0, 0, 0, 0, 0, 1, 0. So now, and all those zeros don't affect it. It's like regular numbers. So now, from this, we can see that it's just 10 to 0, 1, and a 0, 0. So the ORA instruction, we get, we add, so if any of the numbers of the, so if this number is a 1, or if this number is a 1, it's going to be a 1. Okay. That might be a little bit tricky going from the AND, but just know the AND, it must be both, so it's 1 and 1, or 0 and 0. And if it's not, if it's 1 and a 0, it's going to be a 0. And the ORA instruction is going to be a 0 and a 1 equals a 1. That's the only difference. So this means it's going to be 1, 1 and 1, 0, which equals effectively 2 and 3. And if we don't have that, this equals 1 and 2. Actually, no. So this equals 1, and this equals 0, and this equals 3, and this equals 2. if that makes sense. So basically, 1, 0. So those are probably pretty easy to figure out, since 0 and 1 work pretty well in binary, to the decimal system, and hex as well. But this one, it doesn't. Just know the second case, so every 2, so I'm going to try to explain this as clearly as possible. So each byte is divided up into 8 bits, and each time, so each bit, it goes up by 2. So we actually have to start on the other side. So I'm going to start over here. So this one, it represents 2 numbers. Then this number represents 4 numbers. And then this one represents 8 numbers. This one's 16. $32. 64. And lastly, 120. 128. See, this one, and the first one equals 1. So as you saw, we only use 2 bits, so we're only looking at these 2, which means there are only 3 combinations. And keep in mind, 0 also counts in this as a number. So it's 2 only for this one though. So it's basically 2 plus 2. In a logical sense. So you get 4 possible outcomes. So you always add 1 to the end value. So we have. Actually, I think I did this wrong. So it's not actually 0 here. I think we're just supposed to make this 256. Yeah, that makes it work out a little bit better. Not because there's 256 different bytes. So a byte can go from 0 to 256. That's basically all I'm saying there. And this is the reason because of it. So the first 2 has 2 states. And the next bit has 2 states. And then the next one has 2 states, a 1 or a 0. And the next one has 2 states. So it multiplies by 2 each time. And there's 8 of these in a byte. So this is 2 possibilities, 4 possibilities, 8 possibilities, 16, 32, 64 possibilities, 128 possibilities, 256 possibilities. So in this case, we only have 2 bits, so we add the second bit, so we get 2 more possibilities. So twice the amount of possibilities. So that's what we do in this array instruction. Okay, so going on, we AND 3. So basically, let's just make this a little bit easier to read. We're making sure it's only those 2 bits. If it's past that, we just don't read it. Because remembering this AND instruction, so let's say you add, let me just show this off, how this works. So let's say you have, let's set, just for this example, I'm just only going to show what happens if you have 5. So 5 equals percent 0 0 0 0 0 1 0 0. So you can think about it as these 2 equal 4, different possibilities. So 0, 1, 1. Actually, let me just show how that works. So this is 0, this is 1. Then we have 2, 3. And the fifth one of this group is this. So if you get the pattern, then the next one's going to be this, then it's going to be this, this, so on. And that's how you count in binary. But 5, and if we'll ending percent 0, 0, 0, 0, 0, 0, 1, 1, well, that's going to equal, because keep in mind this has, both numbers have to equal one another, so 1 and 0 equals 0, and then 0 and 1 is 0, and then 0 and 1 is 0 again, so it just equals 0. And then it stores that to the frame. So now we're on frame 0 again. So that's how it loops over and over again. And I want to scroll down a little one. So, beautiful. Okay, so this is going to be a little bit complicated. So we'll transfer, so we are moving the frame to Y, the Y register. We're transferring the world number to the, so let me just write this out. So Y equals frame, A equals world num. And this arithmetic logic shift left equals arithmetic shift left is the same as multiplying by 2 if you move it right. Let me just show this out in an example. So we have ASL, let's say the frame, we're on world 3, actually now, so world 4. Yeah, let's use that, and what I mean by 4 is world 5. So you can think about it as world 5. So the computer sees this as 0, 0, 0, 0, 0, 0. Yeah, so it equals that to the, actually let's make it the next one, the next world, just for simplicity. So equals that, and whenever we do the shift, it's going to move all the bits left 1. So now it's going to be this, and this equals 5. This, so remember, so this is 0, so we don't have to count that. And this is going to be 2. Skip this. So this is 2 possibilities, and this is 4 possibilities. So this is right here, this is just 2, and then we got another 2. If you think about it like that, if that makes it easier to think about. But this is now 4, and this is 8. 8 plus 2 is 10. So effectively, we just multiplied by, and let me just explain how I did that quickly. So I saw 10 and 10. I know this is equal to 2, so I said 2, so I just plus this 2 that is in the so we have 2 times 2 times 2. The reason why that occurs, so you have to multiply 2 times 2, is because we have, So, or in this place, so there's 1, 2 bits after it, so you have to times it by 2 that many times. So let's say we had 0, 1, 0, 1, 0, 0, 0. How would you figure this out? It might look complicated at first. Let's add a few more numbers to it just so it's complicated, a little bit more complicated. For first, I would notice that this is 3 because 1, 1 is 3. So I'd begin with, let me make it look nice. So then we notice the next 2 bits is 0, so we don't have to worry about those. And then the next 2 is 1. So we have 1. And how many bits does this have after it? We have 4 after it, so we're going to do times 2 to the 1st plus 0, 1 times 2 to the 6th. And then this is 2 times 2, 4, 8, 16. Times 16, so that's just going to be 16. And then this to the 6th, it's going to be 64. Equals 70, then 80, then 83. And let me verify this calculator. So we have 0, 1, 0, 1, 0, 0, 1, 1, and indeed equals 83 and 53 in hex. So that's a reliable method to do so. You can also do it with counting 4 bits at a time as well. It's just easier to do it in sets of 2 for me. So just know this is multiplying by 2. So we are doing world num times 2 times 2. Maybe if we do it twice. And then you notice we already saved the frame, and because this is where it might be a little bit tricky to figure out what's happening, right? It's just a bit wonky thinking about it, logically speaking. So normally you probably just add the frame, but they wanted to be special and use the ORA function, and this works. There might be a particular reason to use ORA over the regular one. Let me see. So adding takes, so to do it, I would take 4 frames of like computer cycles compared to the ORA. It takes the same, I think. Yeah, it takes the same. I guess they just want to be fancy. But you can also, I believe you can use AND as well. But I'm going to explain why this works with the ORA instruction. So remember, this is, so where there's the world num variables, so the farthest they would be is, okay, so they could be anywhere on this, but know that world 0 or world 1 in this case would start at the very beginning of the index. So effectively, let's say we wanted a world 3 or 4 in this matter, because this is 3 and you add 1 because world number index begins at 0, and we times that by 2. So how we do that is we add a 0 at the front and add a 0 at the front. And remember, the frame is only going to be plus. So the frame is only the first 2 bits. So at max it could be this. It could be this, or even the this, 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 and this. Okay. So I'm just going to use this as an example. So the 1, 1, so whatever world we're on, and then it's going to combine those because it just has to have it's adding these 2 together. If it has a 1 anywhere in it, it goes down. So that's a way to think about that as to why it would work, even though the array function is a little bit complex to use there compared to the add function. I both personally would prefer if it used the add function because it's a little bit more clear as to what it's doing, because you're adding the frame, which makes it easier, I guess. Maybe for debugging purposes, it's a little bit more stable, as in the array function. So let's say we forgot like one of these, it would be here, in which it would still remain at. It would just be there instead, because the array function doesn't add things. It just looks at the bits. And then lastly, we transfer a to x. So a again is the world num. So we're just transferring it back. So this is x equals world num. Did we ever override this? Let me see. Wait, no. A is not the world num. So x equals the frame, the animation we're going to derive from the map animation speed table. So, or not the animation, it's going to be the animation speed, so it's going to be one of these. If you notice, they didn't use so like World 1 uses the same animations, but they could actually use different animations. So it's likely that at one point in time or another, that the game developers thought it would be useful, or the frames would actually change and vary between each frame, which is interesting. Because this could, instead of like doing all that math, they could have just loaded up the x value and I just read from the index like they did for the rest of the values, so like comparing and whatnot. So instead of doing this, they would just load up to x the world num, load a map animation speeds, and call it a day. But instead they want to do this, so we get 4 animation speeds for all of the animations for each world. Then they just throw that to the tick, which is the speed, so that then counts down, as we saw earlier in the code. Then lastly, we load a map chry, which is the animation we have, and y, in case you forgot, is the frame. That's why we switched it up there. And then lastly, we return from this instruction. So basically, we're saying, oh, it's the end of this code, done. And hopefully, this has at least got you aware about what we're going to be doing in this patch, or at least what this patch does, or what this code does at the moment. So when we begin to add additional code, it will be a little bit simpler to understand from a coding perspective, and also increase a little bit of knowledge about how each of these objects work exactly. Because I heard in the previous episodes that it was a little bit complicated to really process and understand what these all mean and do. And hopefully in the next few episodes it becomes a little bit more clear as to what those mean and do, because I've been using them for a while, so I will actually use them the correct way. As from a beginner's perspective, you don't always know exactly how they will operate, so it can get a little bit complicated. Yeah, without further ado, let's, I hope that I made a positive influence and help you learn a little bit more of assembly. And that is the end of episode 1.